Hello and welcome to part 9 of this video lesson in computer network. Today in this video lesson we will be discussing about modulation. Okay, before going to the main topic, let's discuss what is frequency. Now, before going to frequency, we should know what is a signal, alright? Now, everything around you is a signal. The sound that you hear in and around you is a signal. You hear the bird chirping or the animal sound or a human talking is nothing but a signal. Now, what is frequency? Frequency is the number of events occurred at a time at a certain amount of time. So, the word frequent, which means occurring many times in short period, that is nothing but a frequency. So, frequency comes from the word frequent, which means occurring many times. Say for example, you go to a toilet 3 times during class of 1 hour, that is nothing but frequency. You're jumping on your bed for no reason 400 times in 100 minutes, that is nothing but frequency. Now the standard unit of frequency is hertz or etc. Just like unit of measurement is gram or kilogram. So hertz is defined as 1 per second, that is 1 by second. So if you're jumping on your bed 2 times in 1 second, then the frequency of your jumping will be 2 by 1, that is equal to 2 hertz, 60 by 60. A human can hear a sound frequency in between 20 to 20,000 hertz. That is a sound signal that we can hear as a human being. Now let us see some examples here. Suppose you're throwing a paper. In the first picture you can see a person throwing a paper. Now if you're throwing a paper will go to a certain distance. But if you put a stone and a paper together and if you throw, what will happen? The paper will go to certain distance as compared to normal paper. So the distance covered is more in when we wrap a stone in a paper. Just like that. Say for example, human voice. A human voice has certain frequency. When you just speak in a crowded place, people will not able to hear you. But what happens when something is added? Say for example, microphone and speaker is there. What happens when you speak on the microphone, which is having a speaker? The sound signal or the frequency will go at a longer range. This is the example of frequency, where we can say that frequency can be changed by adding something to the frequency. Let us see what is modulation. Modulation is the process of converting data into radio wave by adding information to an electronic or optical carrier signal. Just like a stone wrapped in a paper, where if we throw, it goes to a certain longer distance as compared to a paper that is thrown alone. Just like that, modulation is something which is added, which converts the data into radio waves. 2 signals are involved in modulation process. Message signal, also known as baseband signal, are the band of frequencies representing the original signal. Say for example, your voice, the human voice, is like a baseband signal. This signal is to be transmitted to a receiver. Frequency of message signal is low, just like our human voice. If we shout also, the signal or the frequency will be very low. It will not be heard to a longer distance. Now the other signal involved in modulation is the high frequency sinusoidal wave called the carrier signal. This signal is something like a stone which is wrapped to a human voice so that it will go for a longer distance. Now the frequency of carrier signal is always higher than that of a baseband signal. Now what is this carrier signal? Carrier signal is a signal added to a baseband signal so that it will go for a longer range. Say for example, your human voice. Your human voice when we talk, it will not go for a longer distance. People around you can hear, but people like who is having a distance apart from you will not able to hear. But this carrier signal is like a microphone with a speaker. If you speak over the microphone, your voice will go louder in a longer range. So this carrier signal is always higher than that of a baseband signal. The high frequency carrier wave is able to travel much farther than the baseband signal. This is the reason why carrier signal or carrier wave is always higher. That means it will go to a longer distance. Voice will go higher if we use carrier signal. The baseband signal is combined with the carrier signal for communication, as it allows us to communicate to a further distance. Here the signals are modified. This in simplest term is known as modulation. Here you can see different kinds of signal in the picture. Now say for example, you're talking over the phone. Why do we require a phone to talk when you're talking to your friends? Because just with a human voice it cannot be heard if you're talking to your friend who is in a long distance. So we use carrier signal in a given frequency so that we can hear the voice of your friend over the phone. While talking over the phone, we use this modulation for conversation so that it can reach to your friend. Now there are different types of modulation. Number 1 is amplitude modulation, number 2 frequency modulation, and number 3 phase modulation. We'll be discussing only two: amplitude modulation and frequency modulation. Phase modulation is not there in the syllabus, so we will not discuss about phase modulation. Amplitude modulation. Amplitude modulation is a modulation technique used in electronic communication, just like our mobile phone. This amplitude modulation is used most commonly for transmitting information via radio carrier wave. Take the example of mobile phone. Now mobile phone uses radio wave for transmitting a signal. So we use this amplitude modulation for transmitting the information. In an amplitude modulation, the amplitude, that is the signal strength of a carrier wave, is varied in proportion to that of a message signal being transmitted. The bandwidth occupied by the amplitude modulation signal is twice the bandwidth of the audio signal to be carried. So here the bandwidth that we use for amplitude modulation signal is higher, 2 times the bandwidth of audio signal to be carried. So suppose your voice is a normal voice, so once you use a speaker, it will become double the voice, the loudness will become double. Same is the case here. The bandwidth occupied by the AM signal will be double as compared to the normal audio signal. Now in this picture of amplitude modulation, the green color one is the original signal, or we call it the baseband signal, and the red color one, down one, is nothing but a carrier signal. When the two are combined together, the signal becomes amplitude modulation, which allow us to go for higher range. Now if you see the green color signal, which is the original signal, here the signal is low, and if you see the carrier signal, the signal is high, so the strength of the signal is high. So the strength of the amplitude modulation depends on the carrier signal. So this is nothing but amplitude modulation. So amplitude modulation is used to transmit a signal for higher range with the help of carrier signal. Advantages of amplitude modulation. It is simple to implement. The implementation of amplitude modulation is very simple. You just need to add the carrier signal with the original signal, then amplitude modulation will occur. It can be demodulated using a circuit consisting of very few components. Even by demodulation, modulated means the signal is changed. Now to bring back to its original signal, it can be done easily with the help of few components using a circuit. Now amplitude modulation receiver are very cheap and no specialized components are needed. So if you want to buy amplitude modulation receiver, it is very cheap, so the cost is very low and no specialized components are needed. That means no extra work is needed. Disadvantages of amplitude modulation. It is not efficient in terms of power usage, so the consumption of power is high in amplitude modulation. It is not efficient in terms of its use of bandwidth, requiring a bandwidth equal to twice that of the highest audio frequency. Now even though using bandwidth twice the frequency of audio, still it is not good because it is using double the size, which will affect the bandwidth. It is prone to high level noise because most noise is amplitude based and AM detectors are sensitive to it. Now amplitude modulation, it comes with a voice. Say for example, have you heard, take example of radio. Radio that we use here is amplitude modulation. Now if you change the channel or search for a channel, you'll hear some noise. That is nothing but a noise given by amplitude modulation. So these are the disadvantages of amplitude modulation. Now the application of amplitude modulation. Now it is used in portable two-way radios like walkie-talkie. Now walkie-talkie is used by traffic police. You use amplitude modulation for talking. You can hear the noise, right? That's because noise is generated in amplitude modulation. VHF aircraft radio, the band channel of the frequencies used in civil aviation. Now pilot, when they communicate with the tower signal, mobile tower signal for the traffic, they uses this amplitude modulation for communication. Citizens band radio, a system of short distance radio communication between individuals, typically on selection of 40 channel within 27 megahertz band. Your radio, simple radio, it is used in a simple radio, that is AM. It is used in computer modem. So these are the applications of amplitude modulation. Let us discuss what is frequency modulation. Now frequency modulation is the process in which the frequency of the carrier signal changes with change in the modulating signal. So what does it mean? If there's a change, if the signal is high, then the carrier signal will be high. If the carrier signal is low, then modulating signal will be low. So the frequency modulation changes with the modulating signal. In frequency modulation, the amplitude signal is constant. Due to this, the noise frequency modulation is removed. If you see the amplitude signal in amplitude modulation, it is not constant, it moves up and down. But in frequency modulation, the amplitude signal is constant, it remains constant. That is why the noise in frequency modulation is removed. It is used for many applications including high quality analog sound broadcasting. Say if you have heard about FM radio, Radio Mirchi, these are nothing but frequency modulation. Now in this frequency, in this figure you can see frequency modulation. Now the first one is the information signal, that is nothing but the original signal. Now it needs to be modulated. Now in order to modulate we use carrier signal. Now when they are combined together, frequency modulation signal is formed. Now if you observe in the frequency modulation signal, the signal remains constant, it never goes up and down. That is the reason why noise is being removed in frequency modulation. Advantages of frequency modulation. Resilience to noise. One particular advantage of frequency modulation is its resilience to signal level variation. The modulation is carried only as variation in frequency. Now if you observe in the earlier figure, you can see that frequency modulation, the modulating signal remains constant. This is the reason there is resilience to noise, or noise has been removed. Easy to apply modulation at lower power stage of transmitter. Another advantage of frequency modulation is associated with the transmitter. It is possible to apply the modulation to low power stage of a transmitter. Now even though if the signal that transmit is low, the modulation can be done at a low power stage in a transmitter. It is possible to use efficient RF amplifier with frequency modulating signal. Here RF means radio frequency amplifier. It is possible to use non-linear RF amplifier to amplify FM signal in a transmitter. To this, it can communicate in a two-way system. Say for example, your mobile phone. Your mobile phone is a two-way communication system. You can talk in a two-way. You can talk to your friends. Now talking about walkie-talkie. Walkie-talkie is a two-way but not exactly. So it is possible to use efficient RF amplifier with frequency modulated signal. It is possible to use non-linear RF amplifier. What does it mean? Now the radio frequency is not straight, but still it can be used to amplify FM signal in a transmitter in a tower. The tower is used to transmit a signal. So these are the advantages of frequency modulation. Disadvantages of frequency modulation. Frequency modulation has a little more complicated and slightly more expensive demodulator than the AM. Frequency modulation doesn't have an efficient spectral efficiency as some of the other modulation formats. So these are the disadvantages of frequency modulation. What does it mean by efficient spectral efficiency? This means that the receiving signal of FM signal is small. Applications of frequency modulation. Frequency modulation can be used for broadcasting of FM radio. Now you may have heard about FM radio, Radio Mirchi. These are nothing but a frequency modulation that is used in a radio. It is also used in music synthesizers. It is also used in music synthesis. For example, your Spotify, JioSaavn, or any kind of music. FM frequency is used, or frequency modulation is used. It is used in telemetry, radar, seismic prospecting. Now telemetry is related to earthquake. If earthquake happens, they will measure in the Richter scale how much the earthquake has happened. Radar is especially used in aircraft system, where they locate outsiders, outside plane and all. Monitoring newborns for seizure via EEG. They in order to monitor the heart rate. The signal that we use is nothing but the frequency modulation. These are the applications of frequency modulation.